The next subject इस सेशन में जो हम डिस्कस करेंगे वो है bridge safety. It's not just about the roads, it's not just about how wide the roads are, or how well the roads are. But before we proceed, we have a few very important people that we would like to introduce. Starting with, and it's our pleasure to welcome Major General P. Rahul Sir, the VSM Additional DG Strategic Movement. Can we please extend our warmest welcome? Thank you, sir. And it's been a pleasure to have you. And thank you very much for gracing the occasion. हमारे पास जो next topic of discussion है, वो है bridge safety. An important link for overweight movement. और इसे present करने आ रहे हैं the director for B&S Engineering Pvt. Limited, Shri Alok Bhowmick ji. Can we please request you to join us on stage?
Good evening, all. I think first of all, I would like to congratulate Hydraulic Trailer Owners Association for this 15 years of their glorious journey and 7 years of the portal. It is a real pleasure that, I was also a part of HTOA in bringing out that portal. I represent B&S Engineering Consultants, who are one of the 4 consultants engaged by Hydraulic Trailer Owners Association way back in 2011 for carrying out a study of bridges, whether the bridges can carry these hydraulic loads, overweight consignments. And we came out after a monumental study with some 13 charts, and those charts have been used in the portal, which was issued by Ministry of Transport as a guideline. And I think I take great pleasure and pride that we were associated with the association for bringing out those charts. Now coming to my topic of bridge safety, I would like to say that the demand for this carrying overweight consignment, it has increased rapidly because of various reasons. We all know that. Because of the time constraints, I will not go into the details. But the fact is that this industry is growing very fast. The demand for increased weight to be carried over the road network is also increasing day by day. And if from the perspective of the bridge asset management, it is a real challenge for us as a bridge engineer, because the existing bridges, which are there for maybe more than 60, 70 years, they were originally designed for loads which are far too less than the loads, even the conventional loads that it is carrying now. They are aged, and today we are talking of carrying overweight consignment. So this is a big challenge. How do we, I just want to share some of my thoughts on that. So we know that there has been a significant advancement in the manufacture and transport vehicles, and I think my previous speakers have talked about the the modernization of the fleet and the safety on the cargo part. But the biggest challenge, as I mentioned, is, however, the passage of such overweight consignments over the bridges, which are existing bridges. We have seen in the past several failures of the bridges. Let us come to the reality, and these are matter of concern. These failures have occurred partly because we could not assess the capacity of the bridges before transporting the overweight consignment, or the transporter has not gone through the due diligence and the process, which is very clearly written in the ministry circular, that what all you need to do, checklist, before you can pass the vehicle. Well, just to give you some idea about the work which we have done in 2011 on the basis of the terms of reference given by HTOA, is that we have done a monumental study of existing bridges, simply supported spans ranging from 5 meter to 50 meter. We have studied on 12 different type of superstructures which exist today in our road corridor. We have taken 5 different types of widths. We can have a 2-lane bridge, 2-lane width road, or a 4-lane, or a 6-lane, or an 8-lane. And we have also some 13 type of HT loadings given to us, HT1 to HT13. Plus we have 3 conventional IRC loading. So total there were about 16 loading, spans ranging from 5 to 50 meter, 12 type of superstructure, 5 type of width. All these put together was a monumental task. There were 260 superstructures for each type of superstructure. That means 260 into 8. That is the number of structures which we have designed before coming out with 13 simple graphs. I think all of you are familiar with those graphs who are actually carriers. These are the type of superstructures which we have covered in this guideline. Anything which is not given in this sketch are not covered in the original study, because we had to restrict the study volume so that we can deliver the report fast, and we could do it in about 8 to 9 months. These are the various HT loading which we were given by HTOA, which we have studied. A total, as I mentioned, there were 270 types of structure which have been analyzed with 16 load cases for each structure type. And what we have not done, what has changed thereafter from 2012 today, 10 years, that there are more number of vehicles which are there, though sparingly being used, but they are there, and there is a demand that we need to also check our bridges for these type of loads, though they are sparingly used. We also recognize that the following are the type of superstructures which has not been considered in the original study, because, of course, as I mentioned, we had to restrict our time frame. So these are structures which are prevailing in our road corridor, and unless we sort of have a clear guideline for these type of structures, the transport carriers have to do independent study, case specific, project specific, and this takes a lot of time to get clearances. Now, looking for alternative routes rather than going through the road, because all these bottlenecks are there can be a possibility of taking tentative alternative routes through rail or inland waterway. And now that the government has done a lot of work on the inland waterways, a lot of work is going on. So this is another route which I think is a safe route, but then it can never be door to door. So therefore some stretch has to be on the roads. But then you can reduce significantly if these alternative routes are also explored and developed. Coming to, in last 10, 12 years, there has been significant improvement also in the scientific and the technological development, the way we assess the existing bridges. Originally, when we did the study in 2011-12, it was based on a code which is IRCSP 37. Today also that code exists, but that code is presently under revision. But in last 10 years, the civil engineers and the structural engineers have recognized that there are advancements in the method by which you can assess the bridges. Probably the margin of safety can be assessed properly if we go for a higher level of approximation in the analysis. So new analytical methods have come in, and therefore today, if we have to do the checking of the bridges, probably we will go to level, as of now, we have been going with level 1 and level 2, but a higher level maybe when we are checking an existing bridge for a higher loads, we can go to a higher level of accuracy and approximation, and probably a bridge which we will declare unsafe with level 1, level 2, may be safe when we check at level 3 or level 4. So these are new things which have come up. So what I feel is there is a need for bringing out simplified charts for wider spectrum of bridges, which I mentioned, which is not covered. It is time that I think the Hydraulic Trailer Owners Association think of extending the phase 1 study to phase 2, where all those superstructures which I have shown were not covered in the original study may be included, and also we can go for a higher level of approximation to ensure, and we can come out with those kind of green or red charts which you have seen in the previous guideline. There is need for also creating a database wherever, I will finish in just a minute. There is a need to also create a database whenever we, have a passage of an overweight consignment. Before the consignment passes through the bridge and after, we should have the data, record that data and keep it in a database for future use. If a particular overweight of 300 ton has passed through a particular bridge, this record should be available with the ministry so that in future, if some other overweight consignment passes through the bridge, we should know what was the behavior in the previous one. So this is an important data, and I think I'm not aware whether these data are kept in the data bank. I would like to be enlightened on this. If it is not kept, I think it must be kept, and that data should be made available in public domain. So finally, I would like to simply thank once again HTOA for a milestone which is very well achieved, but I think there are many more to go, and I look forward to not only celebrating 20th year, Silver Jubilee, etc., and we will see more and more improvement in the way the load is carried safely over the road network and the bridge. Thank you.
Thank you, sir. We would request you to please stay back. Can I request Mr. Puneet Agarwal to join us on stage and present a token of appreciation to Sri Alok Bhowmick ji. Thank you, gentlemen.